Today, proving segment relationships and proofs, that's going to be our topic. This is section 2.7. We're going to prove theorems about lines and angles. Now, in your packet, basic postulates for working with segments and lengths are the ruler postulate. You don't have to fill that in. It's already there. And then I believe which establishes number lines is what it says. And then segment addition postulate. That's the biggie. That describes what it means for one point to be between the other two. Segment addition postulate simply says, if you had some segments Q, R, and P, then QR plus RP equals the bigger segment, QP. Okay, that's just an example of segment addition. So whenever you put two segments together, you get a bigger segment. The points are supposed to be collinear. And R would be determined to be between Q and P. Oops, this is your ruler thing. It's just the rulers just are numbered so that you can count off the measurements. That's your ruler postulate. 1 to 1, meaning they're spaced the same. That's what it means by 1 to 1. So if you're on this side, you're in centimeters. This side up here is inches. The segment addition postulate again, if A, B, and C are collinear and B is in between A and C, only if AB plus BC equals AC. We're going to try our first segment proof. So the first thing that in a proof, as we did last week, is putting in a, what's the reason we can say that? It was given. It was given to us. From that, though, if it's said that Q is the midpoint of segment PR, and you look up here at the picture, if Q is the midpoint of P to R, what does that mean? What does a midpoint mean? It's in the middle, so what does it do? Yes, it cuts it into two congruent pieces. That's why it follows the PQ. The distance from P to Q is equal to the distance from Q to R. That is because it said you had a midpoint. So this is definition of midpoint. You may abbreviate midpoint MIDPT and definition DEF. You got to understand where the statements are coming from. We're not making you write them all in. You've got to understand or figure out a reason to be able to say it. Okay? The next thing says R is the midpoint of QS segment. Why? If you don't know, look up here. It has been given. If R is the midpoint of the segment Q to S, then it cut it in half, just like the last midpoint. So these would be equal, making all these segments equal at this point. So it says R is the midpoint of QS, given QR is equal then to RS, those lengths, because of definition of midpoint again. Okay, now we're trying to prove that segment PR is equal to segment QS. When you get here, it looks to me like they're using these two. That's why these arrows are here. PQ equal to QR. See that? PQ and QR. That's here and here. And then they're using the fact that QR is equal to RS, and they're adding that on. So if you add something that's equal to both sides, you are doing the addition property. And you can write add prop. Okay, now we've got PQ equals RS. Well, what did you do to go from 5 to get to 6? What did they do to this to get rid of this? So it would say PQ equals RS. Look right here. What can you do to get rid of this? Yeah. Subtract QR from both sides. This was a subtraction property that got rid of that QR on both sides. Okay, then they went and said, oh, well, if you take segment P or distance from P to Q plus Q to R, you get a whole P to R. PQ plus QR equals PR. They're taking two pieces and putting them together to get a bigger one. We just mentioned today what that's called. We've actually talked about it many, many times, but today I said you're going to use it a lot. If you add two segments to get a bigger segment, it's called and that's another set of them right there, segment addition postulate. That is not the addition property, okay? This is very different. The addition property added an equal amount to both sides. The segment addition postulate says you're adding two segments to get a third segment. Add two segments to get a third segment. And those were two separate statements that did that. Finally, up here on number 5, it says PQ plus QR equals QR plus RS. So since they said these are equal already in the proof, you could go ahead and trade them for the PR and the QS and make a new statement. So you're making a trade by saying, I already know PQ equals RS. Okay, I already know that, PQ plus QR equals PR, QR plus RS equals QS. So I can say these two are equal because these two are equal. So that is just making a trade, which is a substitution. All right, that's the first segment proof. Talk about these properties briefly because we've talked about them before, but now we're applying them to segments. So segment congruence, and segments with the same measure are congruent. Congruent segments are also the following. You can do reflexive property on them, which reflexive property simply has them equal itself, equals itself. The symmetric property, you can flip the sides of the congruence or inequality, or equality, not inequality. The transitive property, which goes 1, 2, if 2, then 3, then you can say 1 and 3. So again, symmetric just switches the sides. AB equals CD, congruent to CD, then CD can be congruent to AB. Transitive, you've got to have 3 different pieces. You drop the middle 2 to get the last 2 equal or congruent. The definition of congruence is used also with segments in that if you want to say that you could segment AB is congruent to segment CD, if that's given, then you can go backwards and say their measures are equal, or you can go, if their measures are equal, they are congruent segments. It adds or takes away that little wavy symbol and the bar above the segments. All right, so we're going to classify or justify each statement with the property of congruence. Okay, I know you got to turn your page, I believe, right? I know you do. This number 1 is simply flop it. So this would be what property? Come on, you guys. I know it's getting end of the day. Symmetric. When you switch sides, it's the symmetric property. Now, if AB, I did fix this. It says RS on your paper. If AB is congruent to RS and RS is congruent to WY, then AB is congruent to WY. That's your 1, 2, 2, 3, 1, 3. So that's transitive, yes. And RS being congruent to itself is reflexive. Okay, we're going to try another proof together, please. Try to follow along and not just zone out and copy down things. I know that can get easy to do at the end of the day. We've got segment AB congruent to segment TE. Now I'm going to mark my pictures. It can help you understand things. And of course it was given. If segments are congruent, then their measures are equal. That's the definition of congruent segs. You can write def congruent segs. Where did line 3 come from? Where did line 3 come from? What are you going to write for a reason? You can write that down. Where do you look if you don't know? Yeah, that's given. Thank you. Thank you. Then you can go to that they are equal in measure then by the same reason as the other one, definition of congruent segs. And we're talking about segments this time. Sometimes it's angles. Then line 5. Well, wait a minute. Let's see. They're taking this statement, AB equals DE, and then they're adding to both sides something that's said to be equal. So if you add something that's equal, you are just doing the addition property. All right, now, you see this? It's two different separate things. You're taking a segment plus a segment equals a segment, or a length plus a length equals a length. What happens when you add two segments? What's the name of the property? What are you adding? Segments. Okay, segment addition property. Okay, now they're going to go and get rid of something on both sides so they can say, all right, it's already been stated that AB plus BC is equal to DE plus EF. So I can say since those are equal, I can make these equal by making a trade, which is a substitution. And finally, if the lengths are equal, then the segments are congruent by definition of congruent segments. Okay, do I need to wait a moment? All right, let's try this one too. We're given PR congruent to QS. I'm going to mark it on the diagram. And that's going to be, I'm going to actually do it underneath here. I'm going to go, because I can't really make a slash on there, so I'm going to have to make a loop from P to R and slash it once. And then I'll make a loop from Q to S and slash it once. Now, those two things have something in common. So in the proof, what you would be trying to do, to be able to prove segment PQ and RS congruent, we're going to need to figure out a way to show that this is in both of them. So I'll show you what I mean. PR is congruent to QS is given. Now we already know PR equals QS then by definition of congruent segments. Looks much like a DEF. I don't know what that looks like. DOF. Okay, if you take two segments, PQ and QR, you'll get a bigger one, PR. That's by the segment addition postulate. Now they're hinting that we want another segment addition postulate. Can somebody come up with something else on that diagram? I got PQ plus QR equals PR already. How about QRN RS? Okay, so QR plus RS equals QS. So that would have been segment addition postulate as well. Now, here's what they're doing. They already have PR equal to QS. We have PR and QS right here equal to something else. So they went and they took these two and set them equal because they made a substitution for equal things to make a new equal things statement, basically. Well, that sounds a little off. And now that you're down to PQ plus QR equals QR plus RS, what could you do now by subtraction? You have a hint right here. Well, what would we do? Line E, take away what? Yeah, take away QR from both sides. So that give us PQ equals RS. And then we could rewrite it to what we really wanted, which is what we wanted to prove, that segment PQ is congruent to segment RS by definition of congruent. I don't know what that congruence of segments. I've never written it like that, but oh well. Okay, we've tried our first segment proofs. You have some homework assigned, but I would like to get the ISN filled out for 2.6 and 2.7. Let's go in there first and just make a few notes about some of these postulates and properties, etc. Sorry. Did I spread these out a little bit for you, I think? Yeah, I did. Give a little bit more room than I have them. I have them pretty tight on here. Yours aren't real far apart either, are they? Addition properly, you add to both sides. I mean, there's only so much I need to say about it. I think you guys are pretty used to it. Subtraction property, you subtract from both sides. And I'm writing it in kind of how you guys say things. Multiplication property, you multiply on both sides by something. Division, you divide both sides. Okay, you don't have to write all that if you don't need to. That's really up to you whether you want that or not. But now we get to something that was new, which was the reflexive property. And that was when it, here's the way to say it. Now, I don't want you to call it the reflexive property, but when you look at your reflection, you see yourself back. It equals, like a reflection equals itself. Maybe you could think of it that way for reflexive property to try to remember it. So A equals A. You could have angle A is congruent to angle A. All of that's reflexive. Segment AB is congruent to segment AB. That's all reflexive property. The symmetric property is when it flips on itself, or much like a heart, usually has symmetry, at least the hearts we draw, not necessarily our hearts, literally. But it flips on itself. Might be a way to describe it. If A equals B, then B equals A. The transitive property is the one that does the 1, 2, 2, 3, 1, 3. And transitive has to do with the order. 1, 2, 2, 3, 1, 3. The substitution property is when you replace stuff with something else that's equal to. And you've been doing the distributive property for years. That's when you multiply through the parentheses. Okay, should I hold off at all for anyone? What's we? Multiply through parentheses. I just made some parentheses. You know what it, like, you remember this? Charlene, you go like, boom, boom. Okay, so let's do our a proof in our notes for solving algebraic steps. The first step is to write down the given. What did you do to get from step 1 to step 2? So you write distributive property. That's the reason you got to say that. What did we do to get from this to this line? What you added, but what do you call that when you put these things together? You're not adding to both sides, right? Combine like terms or simplify. So I don't care which one you would like to use. Simplify is this what we did. And that's a little shorter than writing combine like terms, so it doesn't matter to me which one. Okay, now I would not normally put this line in if I were solving, and I'm okay with you not doing a line if, say, you had a blank algebraic proof to do. I wouldn't mind if you went right from x minus 2 equals 30 to the 8x equals 32. What we're showing, though, here is that we're going to do what to both sides? Add. So that's your addition property of equality. Now, the only thing I can write then, how we got to the 8x equals 32 would be because we showed this line, we would have to say we simplified it. And again, I could have left out and just had this line addition property. Then this shows the division, so I have to write that I did division property. And then simplified to get the final answer. Okay, so I thought maybe because I just said I felt like this one was a little bit overkill. Just to remind you that if you had eliminated this step of writing it, you would have put division on this line. Okay, I don't know if I want to squeeze another in there at this time, but let's go ahead and just get through the segment proof next. Now remember, you're giving the reason to get the next step from one step to the next. That's what we're doing. Been given PQ congruent to QS. I'll mark it on my diagram. If segments are congruent, then their measures are equal by definition of congruent segments. I've been given that QS is equal to ST. I'll mark it on my picture. Therefore, again, segments are measures are equal by definition of congruent segments. And then finally, I can make a trade, or I don't know if I have to say trade, I could use the property that says 1, 2, 2, 3, 1, 3. What property does that? Yes. I would actually, if someone did write substitution, I would accept that as well. But this is more specifically the transitive property, and it's harder to see it when you're working it through a proof as opposed to when it's all written out in one horizontal line and identifying it. Okay, we'll do those later. So right now, was that called 2.7, wasn't it? All right, that's where we're stopping today. I'd like you to work on your packet for 2.7. And if you have any questions, I can help you with that.